how many are like, really, looking for a career in .NET?
I'm on.
Okay, so you are looking for a .NET side. Okay, and Akhil? Everybody's on mute. I mean, see, if you speak, I can at least guide you, like, or, I can clarify your questions.
Me and no.
Okay, Vamshi. Okay, so, and who else? Harish, Siva.
Yeah, bro. Like, I'm looking for career in both the data science and .NET. I mean,
Okay,
I
so basically,
yeah.
okay. Yeah, it's always
Okay,
good. Like,
Akhil
it's
got
always
job
good
in
to.
.NET or not today?
Hmm.
Akhil got job in .NET or not today?
Hey, wow. So time to celebrate the weekend.
Yes, yeah.
Which client it is?
It is Sherwin-Williams, the paint manufacturing company.
Oh, okay. And what is the role?
It's like .NET developer with Power Apps.
Okay. So Power Ops means it is predominantly on the reporting side.
Yeah, it's mostly on the Power Apps for automate and also developing responsive interactive web pages to the user.
Okay. That
Yeah,
means you will be part of the front end as well as back end.
yeah, no.
And when you are going to join?
Probably August 15th.
August 15th. Okay.
Yeah.
Okay. And Harish, Harish, Siva, and Vamshi, you already have some offers, or you still, marketing your profiles?
No, bro. Still marketing. Man. We have
Okay.
started. Yeah. This
Okay. Okay.
still.
Okay. Okay. Fine. Okay. Just thought of giving you some updates on this, because every day, like, we are focusing more on the programming stuff where we are. Okay, so yesterday, I explained you about delegates, right? Okay, so just to recap, delegates are nothing but, kind of a data transmitters from the event, okay, to the event handler. So events are nothing but, a action to a or a response to a action. Like, if you click on the mouse button, it's an action. If you click on right click, it's an action. If you do a mouse over, it's an action, right? So whenever there is an action, okay, so internally it triggers a notification. Okay, so that notification is being carried by delegates, and it sends that notification to the event handler. And event handler looks for the data which has been sent by the delegate, and, whatever it is expected, it does the processing, and if required, it sends the data back to the events via delegates. Okay, so guys, this is predominantly, these events predominantly used in the Windows programming. Okay, standalone applications, because, like, this basically, this concept is built based on the Visual Basic programming language, where we have all these kind of events, and so that they continue to adapt in the, ASP.NET framework also. Okay, so if in case if you are predominantly going to work on the web based applications, okay, so the usage of these delegates is very, very limited. But if it is required very much for the Windows based applications. Okay, so if you if you just recall the yesterday's programs, okay, in the delegates we are doing three kind of steps. One is, first thing is, we are declaring a delegate. Okay, and after declaring the delegate, we are creating a reference, or I can say we are instantiating a object for the delegate. Then after that, you are simply calling the delegate, and that delegate internally invokes the method, right? Just to, let me show you the yesterday's example quickly. Let me show you the first one. Easy. Delegate. Okay, so there are total 3 steps involved. One is declaring the delegate, instantiating, and invoking, right? So here, okay, here first thing is you are, creating, or you're basically declaring the delegate. Okay, you see here, I'm using the delegate keyword. Okay, and this is a public. Okay, doesn't return any value. That's why I said void and delegate name and the parameters which takes. Okay, so you are delegating or you creating a delegate instance, or you're declaring a delegate. Okay, and after that, what you are doing is you are creating a object for this delegate. Okay, so you said new work perform handler. Work perform handler is my delegate. I am creating a object for this. Okay, and I mentioned yesterday that, like, whenever you create a object, okay, for the delegate, you have to pass the event method, because when you say, like, no, hey, like, no, invoke this delegate, internally it is going to invoke this particular method. Okay, so this particular method I have written separately. So declaring the delegate, okay, instantiating the delegate, and invoking the delegate. These 3 methods are there, 3 steps are there actually. Okay, okay, so now if you see here, this is called a single cast delegate. Why it is single cast delegate means, here using this delegate, how many methods I am invoking in the program? I'm invoking only one method, that is manager underscore performed. So only one method
Yeah.
I'm invoking. That's why it is called a single cast delegate. Okay, single cast delegate. But in case, suppose your delegate has to execute more than one method, then you have to write the program little differently, and it is called multicast delegate. Okay, so let me take you to the multicast delegate. Okay, so if you see, I have declared my delegate, okay, under the namespace. So since it is public, okay, I don't have any issues to define outside of the class. And my public class contains, if you see here, it is up to here, my public class, it contains, the name is rectangle. Okay, and I have 2 methods. Okay, I have 2 methods. Okay, and if you just closely observe here, the delegate has 2 parameters which takes double. Okay, and my methods, 2 methods within the class also contains same parameters, double. That means I can attach these 2 methods for this delegate. Okay, so the best way to identify which methods you can attach to a delegate, look at the method signature versus delegate signature. If it is matching, that means you can pass these 2 methods for this delegate, or you can attach. Okay, so I have a rectangle class, 2 methods. Okay, and I explicitly mentioned as event handler method because I am going to attach these 2 methods for this delegate. Okay, now Now, fair enough, there are a couple of delegates and a couple of methods. And if you see here, I have my main method. In the main method, I am creating a object for this rectangle class using the new rectangle. Okay. And now you see here, since my intention is to attach these two methods for the delegate. So what I'm doing, I am creating a delegate. Okay. I have created a delegate for this rectangle delegate. Okay. And for the constructor, I am passing the first method, which is get area. So the object dot get area. So get area is a object, is a method part of rectangle class. And since RECT is my object for the rectangle class, I said, okay, I'm attaching a delegate. Sorry, I'm attaching a method for this delegate, and the method is get area. Okay, but I said that, like, using multicast delegates, you have the ability to attach more than one method also. How do you do? Let's look at this example. Okay, so simply what I'm doing is, okay, +1. So you can remember this, right? This apparatus, it's an incremental, right? When you say, let's say int I equal to I +1, okay, you can say I +1, right, equal to I. You can say like this, right? So similarly, what I'm doing is, by default, whenever you declare a delegate, okay, delegate has the capability to handle more than one method. So then what I'm doing is, I am forcing the delegate to increment by 1 to accept the second method. So first method is get area already there, and by incrementing +1, I'm saying, hey, load the get area also, get perimeter also. That means my delegate now is attached with the two methods, get area and get perimeter. Okay, and now you see here, so now you have two methods. Okay, now here I'm using this get invocation list. See, get invocation list is it's a method already available in the superclass multicast delegate. It is simply, to print the classes associated with these methods. So now we know that we have two methods, okay, and I'm just trying to ensure that, okay, really these two methods are already part of this delegate or not. Okay, so I have declared one array list. Okay, it's array, right? It's array list, and I'm storing, or I'm trying to load the classes associated with the method, with the rect delegate methods. So what happens is, when I execute this statement, it contains the classes of two methods. Okay, and I'm just trying to print, just wanted to show that, really this my delegate contains two methods or not. Okay, it's a get invocation list is already, it's a predefined function or method. I'm trying to simply use it. Okay, you see here, just read out, returns the invocation list of this multi delegate in invocation order. What is it is, and what it returns, an array of delegates whose invocation list collectively match the invocation list of the instance. Okay, so basically this will, give these two methods. Okay, so the first index 0 contains get area, index 1 contains get perimeter, and in this invocation list array, I'm going to store the classes for get area and get perimeter, and that's what I'm trying to print it here, which I can show you during the execution time. Okay, now you see, so fair enough, you have a delegate and you have attached two methods. And now you need to invoke the methods. So to invoke the method, what you're doing, you're simply, trying to call that object. Okay, rect delegate is your object. Okay, and you are passing this two values, right? Because your delegate has two parameters, width and height. So I am passing the width and height here. So what happens? I am invoking the delegate. Okay, so since this delegate now attached to two methods, it will invoke get area method, it will invoke get perimeter method. Okay, and then now you see I am doing a subtraction operation here. What I said is minus equal to, that means I'm trying to reduce the or I'm trying to reduce the delegate count. So delegate has two methods. When I say minus get perimeter, see at this point you know that your delegate contains two methods, right? Get area and get perimeter. Now I said hey, I don't want get perimeter, just remove it. You say minus equal to, you are unloading it or detaching. Okay, it's already mentioned, I think I already mentioned the comments. So removing a method from the delegate object minus, and then again I have invoked my delegate. So since get perimeter is no longer applicable or attached to my delegate, it will only print or invoke another method for this get area. So let's try to run and I will show you how it is working. Okay, you see here, first we try to print the delegates list. Okay, so both the methods contains the same class, so it printed the same class rectangle delete. Okay, right, rectangle delete is your delegate name, so it printed the delegate name here, and then I invoked the first delegate. You see it printed the area as well as perimeter. Then I have removed perimeter and invoked one more time, so it is only invoked area. Okay, so this is the beautiful way of attaching more than one method for delegates. Okay, so remember guys, in general, okay, in general, probably I can explain you here, right? Okay, so now you see here, the delegate holds the reference of a method or a function, right? Because if you see here, this delegate, what it holds a method or function, right? Get area is a method, so it holds method or a function, and when we invoke the delegate, the method it refers to is going to be executed. Okay, and the delegate signature and the method it points to must have the same signature. And while creating the delegate instance, we need to pass the method as a parameter to the delegate constructor. Okay, so while instantiating the delegate object, okay, for a constructor, it's a constructor, right? Because rectangle delegate is your delegate, so for its same name, so it's a constructor. Okay, and you have to pass the method. That's what we did. Get area method we are passing. Just a quick recap about the delegate. Okay, so
Yeah.
what I'm trying to make a statement here is the only way you can pass a method as a parameter is using delegates. Okay,
Yeah.
so far
Yeah.
we have been 15 classes we have been listening, we never passed method as a parameter, right? But it is happening through delegates. That is the one key note to observe. Okay, so multicast I have mentioned, to accept or to attach more than one method. Okay, but again you have to remember that if it is a multicast delegate and if you're going to attach more than one method, the signatures of these methods should remain same, right? So you have two and two with the double. That's why I'm able to attach. Okay, let me take one more example. It's again a multi-delegate only, but we are just going to play a little differently here. Okay, now here see, you have the delegate called math delegate, accepts 2 parameters, returns nothing. Okay, and now I have declared in my new class, program class, I have declared 4 methods, okay, for adding, subtraction, division, and multiplication. And I both have the same kind of parameters, okay, the integer, 2 integers, and no return values. That means I can attach these 4 methods to this delegate, right? Because signature is same. So what I'm doing is here, okay, first in the main thread, I'm creating a object for the program class, okay, where my methods are there, okay. And now, so what I did is I have see, one way is like, you can simply create one delegate and attach everything, but here I'm playing little differently. I'm creating separate delegates for each and every method. For add method, I have delegate 1. For subtraction, I have delegate 2. Like that, I created 4 separate delegates, okay, and I am passing a different method, right? Add, subtract, multiplication, and division, okay. And here you just see, like, uh, here my first 2 methods are static, okay, static. So if you recall the object-oriented programming concept, static means it is method cannot be inherited. You cannot create or you cannot, instantiate these methods. So if you want to invoke the static method, you have to use the program class, because the class is program, right? So here what I'm doing, okay, here what I'm doing, I'm using program class because I cannot instantiate a method or object, okay, for a static method. So that's why I'm using the class dot method, okay. And this the first one, add, is also a static method within the same class, right? That's why even I'm not required to add a class prefix because it already belongs to the same class. So I am invoking or without creating a object, anyway it's not possible, and I don't need to hard code the class also, it's optional, okay. And third one and fourth one is, it's a non-static, right? I did not say static, so it's non-static. That's why I am adding using the object reference. So P is my object for the class program, okay. So 4 different methods. So what I did is I have created 4 separate delegates, okay. And I'm just see, like, how I am playing here. I am saying that, like, I'm creating one more delegate 5, and I'm simply adding +1 delegate, +1 +2 +3 +4. That means you are adding these 4 methods to your delegate 5, which is a multicast delegate, okay. By default it is single cast only. The moment you try to add more than one method, it becomes multicast, okay. And again, same thing, I'm using the get invocation list, okay, to get the delegate name, and I'm trying to print that, okay. And now you can invoke the delegate. So invoking the delegate is simply you have to invoke that object, okay. Or the one more way is you can say the object dot invoke method. This is one more way of, like, so far we are just directly calling the object instance with the required parameters, but if you want, you can use invoke method also. So invoke method with the 20,5. So this my delegate 5 contains 4 methods, so it will simply execute these 4 methods, okay. So with this, like, it will have 4 methods executes. Now you see, what I'm doing is, for this multicast delegate, I am reviewing minus del 2, I'm removing the second method, which is subtraction method. Then again, I'm trying to execute the delegates. So in the first execution, it should print, add, subtraction, multiplication, division. And the second invocation, it should skip the subtraction part. Okay, let's see. Okay. So since I have 4 methods and I'm using the invocation here, invocation list. Okay. And for the 4 methods, it has the same delegate. The delegate is stored in the invocation list. And when I tried to print the invocation list array, it printed my delegates. Okay. And when I execute the first stem, the delegate, it executed all 4 methods: addition, subtraction, multiplication, division. And second time, since I said do not require remove the method for subtraction, so it is only executed addition, multiplication, and division. So basically, the delegate has, you can has the capability to pass the method as a parameter, and also you can execute more than one method. Got it? Okay. So let me close this. Okay, and let me show you one more. Yeah. Okay, here, I have just taken some a real-time example. Okay, so here let's closely observe this. I have only one. Did I keep? Okay. Okay, so here, no, it is not this one. Okay, it's not okay. Next one I will show you about the real-time example. So this is basically, so far, like, if you look at our previous examples, we were only passing the parameters for the methods. We are not returning any values, right? Add, subtraction, you see, like, we are only passing 2 variables, but there is nothing we are returning from the methods. But if required, delegates also has the capability to return back. So look at this diagram. So we are only sending, so far we are only sending the values to the handler to do some method, some functionality. But you have the ability to send back the values to the delegates. Okay, so this example, if you look at this example, I have a delegate. Okay, sample delegate. It doesn't take any parameters as an input, but however, it has a return value which is integer type. Okay, so I have my method, or I have my delegate declared, and if you see, I have 2 methods. Okay, and if you look at these 2 methods, method 1 and method 2, both do not accept any parameters. However, they return integer as a return parameter, which is matching with my delegate signature, right? That means I can attach this 2 methods. Okay, so now look at see. So I have created a delegate. Okay, and I have passed method 1 as the first one, and I have incremented the delegate with the plus equal to, and I said method 2. Okay, so here, so fair enough, we have declared the method, we have instantiated, we have added the methods, and now I am invoking the method. But here you see here, just observe here closely. In previous examples, we were only simply calling like this, like del phi some values, like that we are passing. Okay, but here I am passing the I'm invoking the delegate, but since my delegate returns some values from the handler methods, that is integer type, right? It returns integer type. So I'm trying to store the return value in the another integer here. Okay, and I'm trying to print that. Okay, so the only problem what I see with certain parameters is, see, you are returning the value for two methods, but when you actually get the value back to the delegate, okay, because when you invoke the delegate, what happens, it will invoke method 1 and then it will invoke method 2, then the control comes back to the main method. That means, though delegate is trying to collect the first method value 1, return 1, but since it invoked a return the second method, so the whatever the initial value captured by the delegate 1 is overridden with the second method. So it can only takes the latest return value. When I say latest return value, the latest method, that is method 2. So it will print only this value. If we try to see, I have captured this value from the delegate. I'm trying to print that value. Let's see whether it is going to print 1 or 2. Okay. So method 1 executed, return value is 1. Okay, then it executed method 2, return value is 2. And during that time, the control comes back to the variable. Which variable? This variable. So it contains method 2, return 2. Okay. So guys, I'm just explaining different options in the delegates, different scenarios, so that it will be easy to understand. When you connect all these programs, you will be able to get a clear picture. Okay, so is it clear now? No, passing more than one delegate, but return value is only 1, which is coming from the latest method, which is method 2 here. Okay, so let me take you one more. This time I will show you a real-time example. Okay, so here I have two .cs programs. Okay, so first in the delegate info.cs, if you see, I have my delegate name as, so basically okay, so what this program does is, we send the employee data to the delegate. Okay, and delegate has to invoke the method, and what method has to do is, it has to, when I send 10 employees, okay, so the delegate should take those 10 employees data and pass it on to the method, and method should return back saying who are all employees eligible for the promotion. Okay, so this is my a classic real-time example. Feed in the employee data, invoke the delegate, let delegate handle the mechanism of add shortlisting the promotions, and come back to the main method with the list of folks who are eligible for the promotion. Okay, so now my delegate is eligible to promotion, and I pass the employee data for this method, for this delegate, and it returns Boolean value. So Boolean means what? True or false. So when I pass my data, it may say yes or no. If it is yes, that means I am eligible for the promotion. If it is no, means I am not eligible. Okay, so the delegate is eligible to promotion, which accepts employee data, returns true or false about the promotion. Okay, and the regular class, okay, which contains 4 data members: employee ID, employee name, employee gender, employee experience, and employee salary. In fact, 5 elements. Okay, and I'm using properties, get and set properties, to initialize with the default values. Okay, and I have a method. It's a regular method which is part of this class, employee class. Okay, just look at this, so here this method accepts the employees. We see list means, right? I'm using this new one, list. List means, okay, it's a kind of a array which can store the object references. Means you can pass the multiple objects in an array with the help of list. Okay, it's an array to store the objects. Okay, so this is a method which accepts the employees. Okay, and you just see here I am passing the delegate. You see delegate, right? Eligible to promotion, delegate. I'm passing the delegate. Okay, and since I am passing the list of employees, all the list of employees, so for those list of employees, it does a for loop inside, and it invokes the delegate method. Okay, this is the, you see, is employee eligible? Sorry, okay, I think this is not the one. I think it will show in different one. So here basically for each and every employee, okay, if the employee is eligible for the promotion, it will say promotion or not. Okay, but first thing you have to understand is in this first class I have only delegate declaration and my regular class which contains the employee information, and also it prints whether the employee is promoted or not. But look at the second class. Okay, so here my actual delegate method is here. Okay, you see it takes the employee as a parameter, it returns a boolean value. Okay, so now the promotion logic I have written in my handler method. The promotion logic is the salary is greater than 10,000, you promote it, otherwise don't promote. Okay, so the actual logic is implemented in the delegate handler method. Okay, now look at the flow here. First I have created three objects, emp1 2 3 for the employee class. Okay, and I have a list of employees. So basically it's a array of the similar objects. So I have created a list for the to store the employee objects. Okay, and employee 1, employee 2, employee 3. So I have added three. I've added three employee objects to the array. Array name is list employees. Okay, and then I have instantiated the delegate. Okay, so what is the delegate here? Eligible to promotion. So I've created a reference or instantiated a object, and I am passing my handler method, which is promote, right? Promote. So remember, declaration is done in the previous class, but here in the new class I am instantiating the delegate. Okay, and here I'm not directly invoking the delegate, rather I am invoking a regular method, promote employee method. It's a normal method, okay, not a handler method. Promote employee method, which accepts the list of employees and also a flag eligible to promote or not. So this promote employee is a method in this previous class, right? Why I'm saying it's a normal method? Because it is a part of this regular class, employee class. So it takes the list of employees in an array, right? And for each and every, right? For each and every employee, okay, it checks whether the person is eligible for the promotion or not. Okay, and it prints that value. You see here I have only two names, Priyanka and Anurag. Okay, if you see here I said salary is greater than 10,000, so first one skipped and it only printed the second one and third one. Okay. Fair enough, guys, understood, or it's little complicated, basically because why it become complicated is I'm not directly invoking the delegate handler method. Rather, I am using a one more method to pass the list of employees. Okay. And in this promote employee, okay, in this promote employee, okay, I am actually invoking my handler method. That's why it is little, tricky here. Okay. I know it would be little hard to digest, but I will send you this in a programs and material today and just go through it. And in case if required, probably I can revisit on the next week, if you want some kind of quick refresher. Because I see, pretty much silent. Okay, so let me, so now you're clear with multicast, right? Okay. Okay, so now, so far, like, it's all like, I see it's a Greek and Latin for you guys to understand about delegates. Okay. So, but, I told you that, you worry about this a lot in case, if you're going to work on the Windows programming. If it is web-based, you can at least take it easy and just try to understand at a high level. Okay. But I know this, this delegates is not a easy subject to understand. Okay. But so far, like, we have been creating our own delegates and trying to attach the methods, and we are trying to invoke it. Okay. To make your life easy. Okay. So they understood that, like, hey, it's very difficult to understand these delegates. So what they did is, okay, are probably okay. I will come back to that just after 5 minutes. Okay. But before that, you understand two more concepts. Okay. There is a thing called anonymous method. Okay. Anonymous method means, see, so far you are writing a method, right? For event handler, you are writing a method promote, right? So you are explicitly mentioning a handler method, but in delegates, it is also possible to invoke a delegate handler without method name also. That is called anonymous. You are not giving the method name actually. Okay. If you see here, okay, if you see here, this is my delegate declaration. Okay, and I have instantiated the delegate. But see, previously we were writing the method here somewhere in the bottom, right? Here only I am writing the, the logic. Okay, so you are instantiating the greetings delegate. Okay, GD. Okay, and when you say delegate here, right? By default, it takes internally, it will creates one method name internally. We don't know because we are not mentioning the delegate name here. So internally, it creates a method and it will try to attach this particular statements. That means you are not mentioning the delegate or mentioning the method name explicitly. That's why it is called anonymous method. So normally we create out, then we instantiate, then we invoke. But when you go with anonymous method, right? Okay, you don't need to explicitly mention the method name. Okay, you did not mention the method name here. Simply you're directly, executing a set of statements. But since we are using this delegate keyword, what happens is internally the compiler or the CLR takes care of creating or, by a unique delegate so that it can relate during the execution. This is called, anonymous methods. Okay, just understand the concept. If you're not, not comfortable with the programming, just understand the concept. Okay. Because not everything, in the interview you get, they ask real-time examples. Okay. Sometimes they try to, get the definitions or, your understanding level. So at least you can, convey the theoretical answer and you can, pass that interview. Okay, and one more thing is lambda expressions. Okay. Okay, here, okay. So now this is clear, right? Basically, anonymous means you are not explicitly mentioning the method name. Okay. So, okay, lambda means, okay, before lambda, I will tell you one more thing. So basically, I understood, okay, even I felt that, delegates is little hard to crack. Okay. Because, we are creating the delegate, instantiating and pausing, it's all big headache. Okay. So to make that life easy in the newer versions of .NET, okay, they said like, you don't need to create your own delegate. We are giving you some set of delegates. You go and start using the delegates. Okay, so we have three different type of delegates which already CH provides. Okay, the first one is FUNC, func. Second one is action. Third one is predicate. These three are the generic delegates available in CH which can be consumed by everyone. Okay, so func delegate means it can take up to 16 parameters. When I say 16 parameters, it can take 16 methods. Okay, it can take up to 16 methods. Okay, and it also returns one value. Okay, and if it is action generic, okay, again it takes 16 inputs or 16 methods, but it did not return any value. So if you want to have a delegate which do not return any value, use the action one. But if you want to pass something, also get something, then use func generic. And if you want to have a Boolean output like true or false, then you can use predicate. Okay, so let me show you this through one example. Okay, so here first thing is like, in the previous examples we were declaring the delegate. I have not declared the delegate. Okay, because I am going to use the generic delegates available by the C hash, right? So now you see here. So I did not declare, but I have my own methods, three methods. Method one is to accept three values, return one double value. Method two is to accept three values, but no return. Method three is to accept a one string value and return Boolean value. So basically I have taken three different methods because I wanted to show three different generic ones in the same program. Okay. So the func delegate, as I said, like, it has a capability to accept some parameters and also returns one value. So func delegate, I am invoking and I'm creating the instance as object one. Okay. And if you see here, I said that now func has the capability to take up to 16 parameters. Okay. But I have declared only 4. In this 4, first 3 are the input parameters. Okay. See here, like, func 4 parameters, object 1, new func. I said add number 1. I'm attaching this method add number 1. So add number 1 contains 3 input parameters and 1 output parameter. So this first 3 are int, float are the input, double is the output parameter. So after instantiating the object for func, then I am invoking the method by passing these 3 values and output. Since this delegate returns a value, I'm storing in result. And second one is action. So action is a delegate which can only accept the values or parameters but returns nothing. So if you see the method 2, 3 parameters and void. So if you see action, 3 parameters, okay, and add number 2, the method I have added, and only invoking the object directly. I'm not storing any value as a return because this delegate or this method doesn't return any value. Okay, and third one is it's again a predicate which accepting a string, okay, returning a Boolean value. That value I'm storing in the status. Okay. So if you see here, okay. So the first one is add method. Okay. And it returned the sum of these three numbers. Okay. So those three numbers are available in the result and I printed results. Okay. Second one is the second method. Okay. Second method, within the method itself, I am printing the value because there is no written parameter for the action delegate. Okay. And third one is, it's a predicate Boolean value. I'm passing tetra and it is looking for the length of the string. If it is greater than 5, true or false. So tetra is 5 characters, which is not greater than 5. So it printed false. Right. So this may be, easily understandable. Okay. You can just go through this particular slide. Okay. And refer that example. It's little easy actually comparing to, we creating our own delegates. Okay. And I said that there is one more thing called lambda expressions, right? Let me show you that also. Okay. So in the, okay. So in the lambda, let me show you the theory part. Okay. So first thing is like, in the first example, we are creating the, or we are declaring the delegate, then instantiating, then invoking the method, right? Then with the anonymous method, you did not mention the method name. You are only, okay, you are only declaring and instantiating, and there is no separate method name you defined in the anonymous method. You only said delegate with string name. So internally it creates one method name which we are not aware. That's why we said it's an anonymous method. Okay. But with the lambda expressions, right? With the lambda expression, okay, you really don't need to even mention about this also, delegate or string. If you see here, I try to put all these three different scenarios here. With the handler method, you have to invoke the method completely. You have to write the method. With anonymous method, while instantiating the delegate object, you use a delegate keyword. Okay. So that means internally the CLR, considers this as an anonymous method because you did not mention the method name. Okay. And it will internally align some method and it will execute. But with the lambda expression, okay, it further simplifies. Here you see, I am creating the object for the delegate. Okay. And the left side parameters are the ones which you are passing input parameters for the method. Okay. So this is the name is a variable. You are passing it to the actual implementation. So what is your implementation? Return hello name, welcome to Tetra. So basically this name is being passed to here. It's a placeholder. So you see, first one, we have written explicitly the method name, greetings. Second one, with the anonymous method, we did not mention the method name as greetings, but rather we have used a keyword called delegate. But with the lambda expressions, you don't need to mention the method name, okay? And you don't need to use anonymous method also. Simply, you pass the input parameters from the left-hand side, use this equal to and greater than symbol, and write your method logic inside this braces. Okay, so basically it's basically simplifying. Okay, so if you see here, right? So I have just only taken couple of delegates only. Again, I have taken the generic delegates. So if you see here,
Yeah, no.
it is a function delegate. Okay, I said 4 here. 4 means first 3 are the input, fourth one is the output, right? And you see here, object 1 I am declared. Okay, and what are all the parameters I have to pass? First 3 parameters, right? So those 3 parameters I have mentioned X, Y, Z. So these are all the input parameters. Okay, you see I mentioned here, right? See, towards left side you have to mention the input parameters, then use this equal to greater than and start your logic. So here I have my 3 parameters I am passing. Okay, and then I am writing my own logic. And even so, once this is done, okay, I'm invoking the method. Okay, so this should print the sum of these 3 values. Then another one, action means no return value, only passing the 3 values. So here 3 values I am passing, and 3 again, if you see here, before equal to greater than, I have passing these 3 values as a placeholders X, Y, Z. So it comes to here, it sums up these 3 values and prints the value within the method itself. So when I invoke, it prints that value. See, the reason I'm covering this different scenarios is, see, if because our .NET framework is built, it's way back, right? And some of the programs may be having the old logic, and it's which contains the customized delegates or the generic delegates, we don't know. Okay, so when you start referring that old code, okay, you should be able to understand, because if you don't know about these 3 generic delegates, func, action, okay, it will be like, what is this? It's a, first time you are hearing about this delegate, what is this? You'll get confused. That's why, like, I'm just trying to cover. So though it may not be able to digest everything in one class, at least you will know that, okay, there is 3 different kind of delegates, okay, which we can use to make our life easy, and you can easily recall. Okay, that's why I'm covering this. See, if you want, I can skip this. I can skip and I can only cover at a high level, like, few important topics, and I can skip this. But this delegates and lambda expressions are, it's I see, predominantly in interview also, people specifically ask, what is the purpose of delegates? Why do we use lambda expressions? Okay, so lambda expression is basically, to simplify your code. You don't need to mention the method name, and you make your code very lightweight, right? You did not mention the method name, okay, and you are making that very lightweight. So that's why, like, with the handler method, with anonymous method, with the lambda expression. So 3 ways I have clearly mentioned, so that you can easily, take this space in your brain, and when anyone asks, you can say. So lambda expression is very easily to invoke, okay, a method handler without mentioning the method name, without giving any anonymous method name. Okay, so I think I will stop here. Okay, I'm sure, like, you must be scratching your heads. Okay, but just I will send this deck today, and the programs also. Just go through it, whenever you get some time in the weekend. Try to execute the programs and try to understand. And if you have any questions,
Yeah,
definitely
Anna,
we can
definitely.
we can discuss
Yeah.
on, when we meet on Monday.
Yeah, Anna, happy weekend, Anna.
Okay, so thanks everyone. Happy weekend. We'll meet again on Monday. Monday your time.
Yeah,
Monday
sure,
morning.
Anna. Yeah, Anna.
Yeah. Chalo. Bye. Yeah.
Bye.
Bye.
Bye now.
Bye. Bye.